Hi, welcome to Simple Immunology. My name is Gus. I'm a medical student, a PhD candidate, and an immunology nerd. If you like my videos, give me a thumbs up and subscribe to my channel. In today's video, we'll talk about what the immune system is. In biology, we define a system as a bunch of organs and tissues and cells that work together to execute some sort of function. A simple example would be your musculoskeletal system, which is made up of bones and muscles that work together to help you move. And the same thing applies to the immune system. The immune system is made up of organs, tissues, and cells that work together to protect your body from infections. We divide the immune system into two parts, the innate system and the adaptive system. And I like to compare them based on three properties: time, specificity, and memory. And an easy example to think of how the innate system and the adaptive system compare is to think of buying a suit. You have two options when it comes to buying a suit. You can either go to a store and buy a suit right off the shelf and go home, or you can go to a tailor and who will make a fitted suit for you. An advantage of buying a suit off the shelf is you can get a suit quickly and go home same day. But the disadvantage obviously is, what are the odds that this suit will fit you properly? However, if you go to a tailor, you will get a suit that fits you perfectly, but you will have to wait a few days for it to be ready. So how does that relate to the immune system? The innate system acts almost immediately. And one of the easiest examples is if you take your skin and you make a scratch. Within a matter of minutes, you will see a line forming. This is called inflammation. We'll talk about it in the next video, and it is an example of an innate immune system response. The adaptive system, on the other hand, likes to take some time to develop, likes to take a few days to develop. And in that time, it is adapting to the invader that infected your body. As for specificity, we say the adaptive immune system is very specific, and we define specificity in the previous video. I will hopefully figure out how to put a link to that video somewhere here. If you don't see it, it means I didn't figure it out. If you do see it, it means I figured it out. Either way, I'll still put a link to it down in the description. So the adaptive immune system is specific because it takes its time to adapt to the antigen. And in future video, I will explain what this adaptation looks like. However, the price you pay is the adaptive system has to take some time before it is fully developed. The innate system, on the other hand, is not very specific to the foreign pathogen. For example, I can scratch my hand with a pen, with a knife, with my nails. It doesn't matter, I will always get the same inflammatory response. Once I dig deeper into the components of the innate system and the adaptive system, it will make a lot more sense how the specificity is different between the innate and the adaptive. And I will give you very specific examples. As for the third property, which is memory, the innate system has a slight disadvantage of not having strong memory. The innate system will act quickly, but it will also shut itself down quickly. So the line that you will see here, it comes up after minutes of the scratch, but it will also go away very shortly after. The adaptive system, on the other hand, it took its time to develop and adapt to the foreign pathogen, makes a very specific response to it, and this response will stay with you, and the next time you see the same pathogen again, it will remember that pathogen and it will make an even faster and stronger response. And we talked about positive memory in the previous video. So, to quickly summarize, three properties we use to compare the innate and the adaptive system: time, specificity, and memory. The adaptive system takes time to develop, but it will be specific. The response from the adaptive system will be specific to the pathogen, and the adaptive system will remember the pathogen in the years to come. The innate system, on the other hand, is very fast acting, but unfortunately, it is not as specific and it doesn't have long-term memory. Now that we've compared both systems, please don't make the mistake of thinking they are independent. They are anything but independent. The beauty of the immune system is how its different components communicate and work together. And I hope I will make this very clear in future videos, and I will give you specific examples on how the innate and the adaptive system communicate. By now you might be wondering, why do we have two systems? Why not just one immune system? Why do we have the innate and the adaptive? And the answer is very simple. The adaptive system has the advantage of being specific and has long-term memory, but it is too slow to develop. The pathogens that infect us, they replicate very quickly. And after infection, if they are not controlled, then their numbers will rise up very quickly. We have the innate system to keep the level of pathogens in check. It's not a very specific response. It is effective, but not very specific, so it won't be able to completely eliminate the pathogen completely on its own, but it will keep its level in check. And then with time, your adaptive system kicks in, and then you will have this long-term protection. So now that we've talked about the properties of the innate and the adaptive system, I'm just going to quickly list some components to give you an idea of what I will be talking about in future videos. The adaptive system, we generally say it's made up of your T cells and B cells and antibodies, which are produced by the B cells. The innate system has a lot of components. For example, barriers, which we divide into physical and chemical. An example of a physical barrier is your skin, the first line of defense in your body. An example of a chemical barrier is your stomach acid, which kills any pathogens that you might ingest. Another component is complement, pattern recognition receptors, the PRRs, NK cells, neutrophils, basophils, mast cells, macrophages, dendritic cells, and there are many other components. We will talk about all these components in future videos. If you enjoyed this video as much as I did, please give me a thumbs up, subscribe, and I'll see you in the next one. Cheers.